.3 focuses on exponential functions. Exponential functions are simply equations that have an exponent. When we have an exponential function, the goal is to try to rewrite both sides of your equations with the same base so that we can drop the base. So let's look at an example. For question number 1, the exponent is not attached to a variable, or vice versa. We simply have x equals 4 to the power of 3. So in order to solve it, we just need to evaluate what is 4 to the power of 3. 4 to the power of 3 is 64. Therefore, x is equal to 64. For question 2, however, we are going to rewrite with the same base. Because if we can do that, then we can drop the base. And that is what we are trying to do here. So, when we look at number 2, we have 5 to the power of x is equal to 125. 125 can also be written as 5 to the power of 3. So now both sides of our equation has a base of 5, so we can drop it. And after we drop it, we can set our exponents equal to each other, resulting in the solution x equals positive 3. So let's keep in mind what the exponent rule says when you have a negative exponent. And when you have a negative exponent, in order to make that exponent positive, we move it to the denominator. So this becomes 1 over 5 to the positive 1 is equal to x. 5 to the positive 1 is 5. So our answer is simply x equals 1/5. For question 4, however, that is just a regular quadratic, and we need to find the base that is going to result in an answer of 9. So what number squared is equal to 9? So when we do that, we take our square root, and we actually find that x can equal positive or negative 3, because both of those will give you 9 when you square it. When we look at number 5, again, we have 4 to the power of negative 2, which is equivalent to 1 over 4 to the positive 2. And 4 squared is 16. Therefore, our answer is 16. Number 6 could look a little tricky, but keeping in mind what we know about negative exponents, we know that 1 over 27 is equivalent to 3 to the negative 3. And this is an example where our exponents can cancel out on both sides because they're both the same, meaning that x is equal to 3. So that means that 3 to the power of negative 3 is equal to 1 over 27, which we know is true. Looking at number 7, we know that 625 can be written as 5 to the power of 4. So, because we have the same base on both sides of 5, we can drop our base. And that's going to leave us with negative x equals positive 4. To solve this for x, we need to divide both sides by negative 1. So the solution to this exponential equation is x equals negative 4. Now 1 over 9 and 1 over 81, they both share a base. And there's actually several different ways that we could go about solving this equation. Well, one way is to rewrite both sides with the base 9, because we know that 1 over 9 is equivalent to 9 to the power of -1. And I'm going to put that x back right where it was. And we're going to set that equal to 9 to the power of -2, because 9 to the power of -2 is equal to 1 over 81. And we can drop our base, and after we do that, we're left with -1x is equal to -2. Divide by -1, and our solution would be x equals 2. Questions 9 and 10. The exponents may look a little bit more complicated, but the process will not change. We need to figure out what is the common base. So 8 can be rewritten with a base 2. So I'm not going to change the left side. I'm going to leave that alone because it already has our base of 2. But the 8, I'm going to rewrite this 8 as 2 to the power of 3. Carry down your exponent. And now we both sides have a base of 2. We can just drop our base. And when we drop it, we're left with 3x plus 1 equals 3 times 2x minus 4. We'll distribute our 3. And solve by bringing our like terms to one side. And then we are also going to add our 12 to bring our constants to one side. And that is going to leave us with, sorry about that, that should be plus 12. And that is going to leave us with 13 equals 3x. And when we divide by 3, we're left with x equals 13 over 3. And that is our solution. It's always good to go back to a base 2. When you're looking at two numbers, especially if they're even and you can't quite figure out what that base is, go back to a base 2. In question 10, we actually need to rewrite both sides of the equation, because as it's written right now, there is no way that I can rewrite 32 as 4 to the power of a number. So I have to go back to a number less than 4. So let's go with 2. So 4 is 2 squared, and 32 is 2 to the 5th. So I'm going to carry down my exponents on both sides. And now that I have a common base of 2, I'm going to drop it. Feel free to pause the video at this time and try to solve it out on your own to see if you get the same answer. So if you got x equals 9/5, you got it exactly correct. We have to distribute to eliminate the parentheses. I chose to subtract the 10x to bring x to the right to try to avoid a negative. And after I did that, I had 9 equals 5x, divide both sides by 5, resulting in a solution of x equals 9 over 5. Sometimes the base is already the same and we don't need to rewrite them. Number 11 gives us an example of that exact situation. So we already had a common base, so we can drop it. And from there, solve it. Resulting in 5 equals 2x, or x equals 5 over 2. Question 12. Whenever you see a fraction 1 over a number, then that's a clue that our exponent is negative. So if 4 to the positive 2 is 16, then 4 to the negative 2 is 1 over 16. And now we have our same base. It can drop. Add our 5 to both sides, and that results in x equals 3. Feel free to pause the video at this time and attempt to do questions 13 and 14. So for question 13, if you got x equals 6, that is correct. And for question 14, if you got x equals negative 4, you are also correct. I also want to mention that for question 13, I used the base 4, but you could have also written it with a base 2. So if you wrote it as 2 to the power of 2, and then on the right, 2 to the power of 6, you are still going to end with the exact same answer. The goal is to find the same base. It doesn't matter what it is if you can find that same base. And in many examples, there are multiple bases that would work. 15 is our last question for solving. Both sides have a negative exponent. As always, I challenge you to pause the video and try to work it out. See if you can figure out what that exponent has to be. If you got x equals negative 5 over 2, you are correct. So the only base that we can use for 27 and 9 is 3. 3 to the power of positive 3 is 27. Therefore, 3 to the power of negative 3 is 1 over 27. So I use the base 3. Both sides have a negative exponent, and then I drop the base. After I dropped the base, I solved it as a regular linear equation.